Travis Gillespie here, and we're going to look at the real number system and then start classifying real numbers and working out some problems. But let's see if we can try to do each of these within 5 minutes. That's a good time limit. So let's start with where we get our number system. Where does it come from? So the first thing that you start out with, maybe as a young kid, you start watching the TV show Sesame Street, and you start to learn to count by 1, 2, 3, 4, and so on. This probably goes on until you know how to count till 10. And from there, you become so sophisticated, you're a little bit older, you say, hey, I need more. But before we move forward, let's title this. Um, what we call this is the counting or natural numbers. So let's just call them counting. Or counting or natural numbers. Because you're learning to count here, and I'll change the color and box it up. And then you become so sophisticated, you say, wait a second, I'm a little bit older. I know a little bit more. I understand a little bit more. Let's move on to a new show. I'm going to start watching Barney instead of Sesame Street. And I'm going to learn to count not to 10, but count to 20. And you learn one other big fact, that numbers don't start at 1. They start at the number 0. You count 1, 2, 3, and then you count on until 20 or so. And we call these numbers our whole numbers. So our whole numbers, they include the counting numbers 1, 2, 3, 4, and so on, but they also include 0. That's the big one there. And we'll box that guy up to show that it includes not only 0, but all of the counting numbers. So the counting numbers are a part of the whole number system. Moving on from there, you start to realize, hey, there's really more to life still. You want to go travel and see the world. So as a kid, you decide that you're going to travel to see some family in a colder part of the area. You probably grew up in Texas your whole life, and it's warm there. So we still are dealing with our whole number system that we have. And then you realize, hey, I'm going to spend all my money, travel all the way to Alaska and visit my family in the cold, but you brought all your warm travel gear. So now you're cold and you don't have any money to buy new clothes, so you got to borrow money. Because you had 0, now you are borrowing, you have less than 0. Or because it's cold outside, it was 0 degrees, but now it's less than 0 degrees. So now, again, or we could say it's below 0. So we're dealing with negative numbers, and these negative numbers continue on in the equal and opposite direction as the positive numbers. So on. We call these our integers. Integers include all values, negative and positive, including 0. Here's, there we go. And let's box that dude up. Again, we'll use green. All right, and let's move forward from here. Because you grow up, you're in the 3rd grade, you've moved on from travels, and you're back in class, and you want to have a, I don't know, a little party, and you think you're going to have pizza with your friends, go out on dates or whatever, but you're learning about fractions here, and you realize that you're not going to have a whole cake to yourself. You're going to have a piece of cake or a piece of pizza or a piece of the brownie set. So you're not having the whole set, but you're just having a piece of. So we've got our numbers that are negative still. We've got our positive numbers, but between 0 and 1, you only get a part of. So now, instead of having a whole piece, you're having a fraction of a piece. So a quarter of a piece, or half of a piece, half of the whole, and so on. And let's say, hey, 2/3, and let's say, okay, and then 1, and then it continues on. So we can box this guy up now. But before we do, let's call this this is our rational numbers. And rational numbers are made up of integers that create ratios or fractions, because there is an integer in the numerator, an integer in the denominator, and it's a non-zero number in the denominator. So these are all I wrote ratios, but it should be rational numbers, because integers create the ratios, which are basically fractions. And fractions create decimals. So our decimals that they create are repeating decimals, such as 0.6666666, or etc. Repeating decimals, or they are terminating decimals, such as if I had the number 2.58 or 0.5, the decimal is terminating. So let's box this guy up. So disconnected from the terminating decimals, or the terminating number, not terminating, our rational numbers. Disconnected from them is this whole nother set called our irrational numbers. So we'll write that in yellow. Irrational numbers. And irrational numbers, what they do, I just broke the 5-minute barrier a minute ago, or 20 seconds ago. I'll try to wrap this up soon. Rational numbers are numbers that they are non-repeating decimals, or non-terminating decimals. So what kind of numbers could these be? That's an I, and that's supposed to be an I as well. These can be numbers such as pi, and or the square root of 3. We'll look at these numbers later, or the square root of 10. So these are disconnected from, they are not a part of the rational number system, which in the rational numbers include counting numbers, whole numbers, integers, but these are irrational. But both systems, rational and irrational numbers, they're part of a larger system called the real numbers. The real number system. Or just real number system. Real numbers. So again, counting numbers, whole numbers, integers, rational numbers, and irrational numbers are a part of the real number system. I'm going to box it up here. We'll do a box, and let's make this one pink. I'm going to scroll down just a little bit here. From here, go all the way up. There we go. And we're done.